All right, you've learned some AWS vocabulary, some of the concepts behind cloud computing, as well as some of the specifics around cloud identity and access management. As a refresher, let's take a look at the architecture diagram we'll be building out. You'll remember that it's fairly complicated at a glance. There are many different services working together to host this solution, and to get this entire thing built out this way will take some time and understanding. You'll get the opportunity to see how each piece is built throughout the upcoming lessons. What I want to do now is show you how we are going to host our employee directory application using a service called Amazon EC2, which has been mentioned in previous videos. I find that the best way for me to explain to you how these services work is to show you how they work. So, what we are going to do is we are going to call Ceph in here to launch an Amazon EC2 instance and host the employee directory application using the defaults provided by AWS. AWS provides you with something called a default VPC, which is a private network for your AWS resources. Every EC2 instance you launch using AWS must live inside of a network. So in order to complete this demo with the limited amount of information that we have shown you about AWS services, we will be using the default network provided by AWS, and we will accept most of the default values for launching an EC2 instance. Let's bring Ceph in for some help with this one. Hey, Ceph.
Hey, Morgan. Is it time to launch our first EC2 instance?
It is. We'll be using the default VPC to launch this first instance, and we will configure the bare minimum to get our application up and running. Sound good?
Yep, I got it. Let's get started. I'm already in the EC2 management console, and I will navigate to the service Amazon EC2. As Morgan already mentioned, Amazon EC2 is a compute service that allows you to host virtual machines. You'll learn a lot about this topic coming up soon, but for now, we are going to simply create an EC2 instance to try and help you wrap your mind around using AWS services on demand. From here, we'll launch a new EC2 instance. An instance is just what we call one single virtual machine. Now we have to select the configurations for this EC2 instance. You will go over these configurations in detail later. We can give this instance a name. I'll call it Employee Web App, and then we will select the free tier eligible options using a Linux AMI or Amazon machine image. And then scrolling down to the next section, we will select the free tier eligible T2 Micro for the instance type. Next, we normally need to select a key pair. This would be used to SSH into the instance. But we won't need to do this, so I'm going to select Proceed without a key pair and continue scrolling to the network settings. Here, we will select the network, so looking at network settings, we will click Edit. Then we can select the VPC and subnet for this instance, and as we discussed earlier, we will use the default VPC and leave the subnet at No Preference. The default VPC has configurations in place that make this experimentation process a lot easier when you're first getting started with AWS. Again, we will define all of these things later. Continuing on with network settings, we will create a new security group, which is an instance-level firewall that will allow HTTP and HTTPS traffic in to reach the instance. So we will add inbound rules for both of those. Now we will scroll down and expand Advanced Details. We will accept most of the defaults here except the IAM instance profile and user data, which we will provide a value for. For the IAM instance profile, we will use the IAM role that will be used by the application, though this won't come into play until later when we have our S3 bucket created. But for now, let's click the dropdown and select that IAM role. Now, scrolling down to the user data, this is a script that is going to run when the instance boots up. Let's go ahead and paste in our user data script. This script will download the source code for the app, start the web server, and kick off the application code so it's ready to start handling requests. While you could have launched the instance, then connected to it via SSH, configured and started your application manually, we have decided to use a script to automate this process on launch. All right, now we can click Launch Instance. It can take a few minutes for the instance to boot up, so let's wait for that. And now it's up and running. To access the instance, copy the IP address from the details listed below, paste it into a new browser tab, and there you go. It's up and ready to go. Morgan, what do you think?
That looked great. It's exactly what I would expect at this point because there is no data being served from a database. So I expect to see just a home page with no info. So that's great. Thank you, Seth, for walking us through that. In upcoming lessons, we will discuss the specifics of not only EC2, but also networking on AWS, and you'll understand how everything we just kind of glossed over actually works. So stay tuned. Hey everyone, and welcome back. So far, you've been learning all about some higher level concepts regarding AWS, making sure you understand AWS in general, the global infrastructure, as well as setting up an account and providing yourself the right level of permissions. But you may also remember that we ended the last lesson by launching an EC2 instance to host our application. An EC2 instance is simply just a form of compute, meaning it gives our application power in the form of CPU, memory, and networking capacity so that we can process our users' requests. This concept of compute leads us into the next lesson, where we discuss your compute options on AWS. Of course, you've already seen one of these options, EC2, but we'll also discuss other common solutions such as container services like Amazon Elastic Container Service, or ECS, and Amazon Elastic Kubernetes Service, or EKS, as well as serverless options like AWS Lambda. After the upcoming lessons, you'll not only understand each of these compute services, but you'll also be able to compare them to one another. That way, you'll know how and when to apply each service to different use cases. You'll get an opportunity to see more demos with Amazon EC2, and we will go further into the details throughout this week. But as you imagine, we can't just launch this EC2 instance into space, right? We have to put it somewhere. And where do we put it? Well, we put it in a network that we'll need to customize for our application. Every EC2 instance needs to exist inside of a network, and on AWS, those networks are called VPCs. We'll learn all about networking on AWS using VPCs, but rest assured, this won't be too hard. We'll give you all the information you need to launch an EC2 instance into a VPC. All right, so that's what is on deck. Also, make sure you are checking out the readings that follow the videos. There's additional information in those readings that you won't see in the videos, like use cases, features we didn't have time to cover, and more. All right, I think that it's time for us to get started. Enjoy the lessons, and I will see you soon. Let's talk about compute. Every business needs raw compute capacity to run applications. These applications could be web servers, batch jobs, databases, HR software, machine learning, or just about whatever you can think of. The time, money, and effort it takes to get up and running with on-premises computing resources are fairly high. When you own your own fleet of physical servers, you first have to do a bunch of research to see what type of servers you want to buy and how many you need to buy. Then you need to purchase that hardware upfront. You'll wait multiple weeks or months for servers to be delivered. You then take them to a data center space that you own or rent to install them, rack and stack them, and wire them all up. Then you make sure the servers are secured, powered up, and ready to be used. Only then can you begin to host your applications on top of these servers. The worst part is, once you buy these servers, you are stuck with them, whether you use them or not. It's not easy to just suddenly provision more physical compute capacity when you need it, and it's even harder to get your money back on servers you no longer need. It's impossible to get the time back. Following a compute as a service model is much easier to get started and support operations over time. AWS took care of the hard part for you already as far as getting started goes. AWS already built and secured the data centers. AWS has already bought the servers, racked them and stacked them, and they are already online, ready to be used. In a previous lesson, we showed you how to launch the employee directory application with Amazon EC2. We didn't really talk about the details, how EC2 works, what configurations exist for it, and we definitely didn't discuss any other compute options that exist on AWS. AWS has different services for different use cases, and Amazon EC2 is one of the basic AWS services that are important to understand. We'll be spending most of our time in these upcoming lessons exploring EC2. That being said, though virtual machines like EC2 are great, there are other compute services out there too, like container services and serverless compute. You'll learn about these other compute options and their use cases. Don't always assume that VMs are the default answer. Sometimes it makes sense to architect applications for serverless compute or containers from the start, depending on what you are building and what you are optimizing for. EC2 instances give you a lot of flexibility and control in the cloud, and you configure them to meet your needs. You can provision one or many instances easily, and at the end of the billing cycle, you only pay for what you use, either per second or per hour, depending on the type of the instance. When you no longer need an instance, you can terminate or stop the instance, and you will stop incurring charges. Not all servers are the same, and you are probably looking to run a specific type of operating system on your EC2 instance. AWS supports a range of operating systems, including Linux, macOS, Ubuntu, Windows, and more. To select the operating system for your server, you must choose an Amazon Machine Image or an AMI. The AMI contains information about how you want your instance to be configured, including the operating system, possible applications to be pre-installed on that instance upon launch, and other configurations. You can launch one or many instances from a single AMI, which would create multiple instances that all have the same configurations. Some AMIs are provided by AWS, whereas others are provided by the community and can be found using the AWS Marketplace, or you can build your own custom AMIs as needed. For example, Amazon Linux 2 is the AMI we selected when we launched our employee directory application. This AMI is provided by AWS, and it's essentially a pre-built EC2 optimized Linux image that has long-term support provided by AWS. Beyond the properties determined by the AMI, you can also configure the instance type and size, which correspond to the amount of compute, memory, and network capabilities available per instance. Different applications have different hardware requirements, and choosing the instance type for your application gives you the ability to pick the hardware that it runs on. It's also really nice that you have a wide variety of choices, as it's hard to achieve that same level of variety with on-premises resources. The instance types you can choose from are grouped for use cases like compute optimized, memory optimized, storage optimized instances, and more. There's a list of instance types you can find in the AWS documentation, and you can expect this page to be updated regularly as new instance types are released. For example, the G instance family are optimized for graphics-intensive applications, which would work best for use cases such as 3D visualizations or video encoding, whereas the M5 general-purpose EC2 instance family provides a balance of resources and are great for applications that use these resources in equal proportions, like web servers, our employee directory application example, or code repositories. When you are launching an EC2 instance, you will see something like this when selecting an instance type and size. The T3 or A1 is the instance type that determines the blend of hardware capabilities, then the dot, then the size, like small, medium, large. It goes down to nano and up to many, many extra large sizes. The great thing about this type of selection existing right at your fingertips is that you are no longer locked into hardware decisions up front. You can choose an initial EC2 instance type, evaluate its performance for your specific use case, and then later change it to a different type that is better suited for the application. EC2 is also resizable with a few clicks in the console, or can be done programmatically through an API call. All of these configurations being available to you via API enables you to embrace change over time easily as your workloads mature and change. So, okay. Virtual machines are cool and totally not new, so how exactly does this impact your business? Well, the important thing is this: the flexible and low-cost nature of EC2 instances, as well as the ease of provisioning servers, allows for programmers and businesses to innovate more quickly by spinning up servers for a short amount of time to run experiments and find optimal configurations for your applications. EC2 offers a wide variety of hardware options to choose from, so you can optimize your solutions by selecting the right EC2 instance type for your application. And then you can optimize even further by right-sizing the resource, or selecting an instance size that is appropriate for your application and not over-provisioning like is often done on-premises. This type of optimization is hard to achieve on your own because with traditional on-premises deployments, you are working with hardware constraints that simply don't exist in the same way with the cloud. The ability to adapt to changes and choose really specific configurations for your virtual machines all through a couple of API calls is very powerful. And EC2 is really just the beginning of the story. One of the main reasons why EC2 provides so much value is the fact that you can provision new EC2 instances on demand, and just as easily you can get rid of instances that you no longer need. In most cases, you only get charged for instances that are currently running. EC2 allows you to stop and start instances at will, which enables you to treat your fleet of EC2 instances as elastic, scaling them in or out. Then at the end of the billing cycle, you only pay for what you use. We are building up to the idea of scaling your fleet of EC2 instances in and out to serve demand. But before we get there, it's important to understand some of the more basic things about EC2. Let's talk about the EC2 instance lifecycle. An Amazon EC2 instance transitions through different states from the moment you launch it through to its termination. You launch an EC2 instance from an AMI, and as you learned in a previous lesson, once the EC2 instance is launched, it enters a pending state. This state is essentially your VM booting up. Once the instance is ready for use, it enters the running state. In the running state, you will be charged for the EC2 instance. From running, you have a couple of different options. You can reboot the instance, which is similar to rebooting, say, your laptop. It turns off, then it turns back on again. Pretty straightforward. You can also choose to stop your instance. It will enter a stopping phase, then enter the stopped phase. Stopping an instance is like powering down your laptop. You can always turn it back on, and it will go through its usual boot sequence, moving through the pending state and back to the running state. The other option, which is similar to stop, is to stop hibernate your instance. This also enters the stopping phase and then the stopped phase. You can compare this to how you lock your laptop and shut the lid, but when you open it back up, everything is still in place where you left it. No boot sequence required. You are back up and running after a couple of seconds of the computer waking up. Since the state of the machine was written to memory when you stopped it, the state of the machine can be drawn from memory and put back into place. Then you're back up and running. Now, the last option depicted here is the terminate option. When you terminate an instance, it enters the shutting down phase, then the terminated phase. Terminating an EC2 instance is like taking your laptop out for a long boat ride off the coast and throwing it into the ocean, getting rid of it forever. It's now lost in the great blue sea. There is no hope of finding your laptop on an island shipwrecked one day, having been saved after spelling SOS in the sand. Anyways, I hope you had any data or state stored on that instance backed up, because once you terminate an instance, it's gone. That being said, there is a feature called termination protection that you can enable if you're worried about instances being terminated accidentally. You also will learn about persistent storage and EC2 in future lessons, so don't fret. We will show you ways you can make sure your data sticks around, even if the EC2 instance doesn't. So that is the EC2 instance lifecycle. It's definitely a good idea to remember how all of this works if you plan on using EC2 to host your applications. And don't think of terminating instances as a bad thing. If your EC2 instance is having technical trouble for one reason or another, maybe it needs an update or a patch, instead of logging into the instance to fix it or install software, you can launch a new one with the new changes in its place, and then you could terminate the old instance, having the new instance take that place. You of course can do in-place updates as well, but just know that you have the option to decide how to handle these sorts of tasks. You can launch or terminate EC2 instances to meet demand. So as demand for your application increases, you can launch more instances, and as it decreases, you can terminate instances. This keeps your EC2 instance fleet in line with demand. So again, terminating an instance isn't a bad thing and shouldn't be feared. Now, let's discuss the cost aspect of this. You only get charged for an EC2 instance if you're in the running state, or if you are in the stopping state when preparing to hibernate. This means that you can stop instances when they aren't in use. Say if you have applications that are only used during the work week. Run them when your employees are clocked in, and then stop them when they aren't. Remember, you can always start from a stop state, allowing them to resume working when necessary.
In this next exercise, you're going to put all this new EC2 knowledge to good use. You're going to launch a new Amazon EC2 instance into your default VPC, just as we did for our demo in a previous lesson. You'll select an AMI, an instance type and size, configure the instance, and launch it. Part of the configuration will be to paste a user data script into the advanced configurations. This user data script is a script that runs when an EC2 instance is booted up for the first time. This is most commonly used to download and configure any software packages or dependencies that are needed for the application running on the instance. It's good for you to pay close attention to these sorts of details as you move through the exercise, especially if you plan on using EC2 outside of a classroom environment. Once your EC2 instance is booted up, you'll be able to send a request to the employee directory application and view its response in the browser. This EC2 instance will not yet be connected to any backend database to store employee information, so the expected result is simply the home page loading with no data displayed. If you are having trouble, try going back a few steps and making sure you have followed all of the directions carefully. Also, please note that it can take a few minutes for the employee directory application to be available after launch, so give it ample time to boot up. Once you are done verifying your EC2 instance is up and running and configured correctly, you will then stop the instance to view the state change. Then finally, you'll terminate the instance as some cleanup. In a future exercise, you will relaunch the application but using your own VPC. The default network settings we are using for this lab are not secure, and I do not recommend you continue to use these settings throughout the course. This is simply a proof of concept, so you can have experience going into the next lesson, making it easier to wrap your mind around.
Hello everyone. In this video, we are going to launch the employee directory application on an Amazon EC2 instance using the default VPC. So you can see I'm already in the AWS console and I'm going to navigate to the EC2 dashboard. From here, I want to launch a new instance. So I'm going to select launch instance and then select launch instance again. And now this brings us to a page where we can provide the configurations for our EC2 instance. I'm going to give this a name, employee directory app, and then we can scroll down and we can view what AMI we want to choose. The AMI is the Amazon Machine Image, and this is a template that contains the software configuration for your instance on boot, like the operating system, any sort of application server, or any applications that you want to have pre-installed when you launch your instance. We're going to be using the Amazon Linux 2023 AMI for this, though you could browse the AWS Marketplace to get access to the different types of AMIs that vendors offer. So if you're using some sort of third-party software that you want to launch on an EC2 instance, they might have an AMI out there that you could use to make your life a little bit simpler. You also can create and manage your own AMIs and share them internally within your organization to say you can only launch an EC2 instance using one of our approved AMIs that might have some specific security or compliance sort of packages pre-installed. That's another option. So leaving the Amazon Linux 2023 AMI selected, I'm going to scroll down, and then we can select our instance type. The instance type will determine how much CPU, how much memory, what types of hardware is available to you on this instance. Some instances come with a GPU, for example. In this case, we are going to use the free tier eligible EC2 instance type, T2 Micro, which is the default that's selected. So we'll leave that the way it is. Then we can scroll down and select whether we want to use a key pair. The key pair is going to allow you to have access to this instance doing something like SSH. I'm going to select proceed without a key pair because if I need to connect to this instance, I'm going to use the connect button in the AWS console where I don't need to have a key pair to connect to this instance to view things like logs. Then scrolling down some more, we then can configure our network settings. This is using a default VPC and a default subnet. This default VPC is going to have subnets that have internet access, so meaning that there is an internet gateway attached to this VPC that allows internet traffic to flow into this default VPC. You'll learn more about VPCs coming up, but just understand that this default VPC does allow public internet access, which is good for our use case, but might not be great for other use cases where you would more than likely put your instance behind something like a load balancer, and then you would use private subnets. But we want to be able to access this instance directly. So with that in mind, we're going to use the default VPC, and we're also going to leave this auto-assign public IP to enable. And this will allow our EC2 instance to have a publicly reachable IP address once it's been launched. Then scrolling down a little bit more, we have to configure our firewall. This is going to be our security group. Security groups are instance level firewalls. We want to disable traffic from SSH because we're not going to need that. Then we're going to allow HTTPS and allow HTTP. In our application, we're going to be using HTTP directly. Then scrolling down, we can configure some storage. We're going to leave our root volume here, but we're not going to add any more EBS volumes. Then we can expand the advanced details section, and then we need to select an IAM instance profile. In this case, I'll be selecting the employee web app role, and this role has permissions attached to it to allow whoever's using the role to make calls to S3 or to DynamoDB. We know that our application has some code that's running that's going to be making API calls to S3 and DynamoDB. We need to allow our AWS SDK to actually get access to these credentials. And the way that we do that is through this IAM instance profile. So we're associating this role with this instance profile that will allow our code to get access to these temporary credentials. Then scrolling down some more, we will come to the user data section. And this is where you can provide a bash script that will run on launch. So this script here is what's going to be used to download and install our application. Our application was written in Python using Flask as the web server, and this is going to be for our employee directory application. So on the first line, we are just declaring that this is a bash script. Then we are using wget to download a zip file from S3. So we hosted this zip file in an S3 bucket for this to be downloaded. Then we're unzipping that, and then we're changing directories into that new directory. Then we're using yum to install Python 3 and pip. Then we're using pip to install any dependencies for our Flask application, which will all be listed in a file called requirements.txt, which got downloaded from this zip file. Then we're installing a package called stress. This stress package is going to be used to simulate a CPU spike on this instance, which is going to allow us to simulate auto-scaling whenever we use Amazon EC2 auto-scaling in a future lesson. Then we have 3 different environment variables, one for our photos bucket. We're going to be using S3 to store our photos. We don't have that value yet, so we'll just leave this placeholder there. Then we have the default region. We're operating out of Oregon. And then we have our Dynamo mode on, and this means that we want our application to use DynamoDB. And then we're running this application and hosting it on port 80. Now we can select launch instance, and this will begin to go build out the different things that we need, like our security group. And we can see that our instance has launched. Now, if I select this instance ID, that brings us to a page where we can then select our instance and view some information about it. We can see things like our public IP address, our private IP address, and our public DNS name, but we can't access this directly yet. We can see that our instance state is running, but if I refresh this, you can see that we have some status checks that are still initializing. I want to wait until both of these status checks have passed, so we'll give this a few minutes and then we'll come back once it's ready. Okay, we're back and we can see that our instance state is running and the status checks have passed. Now, if I select this instance again, we can then open up our IP address in a new tab. All right, and we can see that our employee directory application has been opened in a new tab and we have an empty employee directory. This is exactly what we would expect at this point, as we don't have a place to store our photos or the employee information with our S3 bucket or DynamoDB table. We're going to look at how to build out a custom network for this, the S3 bucket, and the DynamoDB table, and make all of this highly available in an upcoming lesson, so stay tuned.